Okay. Once you folded the 6 flaps inward, you should have something that looks like this. Here's what we're going to title this. Up in the top left-hand flap, on the outside of it, at the top of it, you're going to write the word fractions. You're going to write the word fractions. So on this flap, or this entire thing that we're going to do is we're going to write everything you need to know about fractions.
I'll be writing you know you open it up, are we going to be writing in there?
Yep.
I'll
Okay. Some rules with fractions. Always simplify. If you have fractions, if you're dealing with fractions, one thing you need to always remember is you always need to simplify. And then here we are always going to use improper fractions. We will go over what an improper fraction is, but we're going to always use improper when they're necessary. We'll never use a mixed number. And the last thing with fractions is you need to remember to learn to love them.
Well, we need to.
Did they change we're in 6th grade and not allowed to use calculator anymore?
Yes.
They limited it.
Well, see, I tried to do like how my cousin with his mixed numbers and fractional. I could do that. I didn't know how to turn it.
I had to go.
I tried to look. He wasn't even there.
I was.
Yeah, they're switching now where you can use a basic four-button calculator.
And he didn't even know how to turn them into fractions. I'm like, well, I guess my screw.
All right. Okay. So fractions, you need to always simplify. You always need to always use improper fractions. Never use mixed numbers. And then just get used to them at least, if not learn to love them, because we're going to be using them all year.
I don't even love half my family. You're supposed to love fractions. Like,
That's true.
that don't work. Sorry.
Okay, so opening that flap up, over here on the left-hand side, fractions are always written part to whole, part over whole. So an example of a fraction would be 3/8. So if we're talking about if we got an 8-piece pizza and we have 3 pieces of the 8-piece pizza, then we have 3/8 of the pizza. 3 is the part, 8 is the whole. What is the name for the number 3 in this problem?
Part.
No,
It is the numerator. The numerator tells you how many. So what we're talking about is we have 3 of them. The bottom is called the denominator. And the denominator tells you what size. So we're talking about having 3 pieces of a pizza, and they all are of the size of being an 1/8 of the entire pizza. So the top number tells you how many you have, the bottom number tells you the size. Does anyone know what the fraction bar is called? There's actually a term for it.
it's point of
Oh, Nicholas.
It's called a vinculum.
That was my next guess. That was my next guess.
Sure. Fraction bar is called a vinculum. So even like if the number 3.866 repeating, that repeating bar is called a vinculum.
What about
What if?
That's not anything that's necessary. Now over here, if we were to draw this picture, okay, if we were to draw this picture, the one on the left represents what fraction? 3/6. The other one represents 1/2, and these are the same because having 3 out of 6 pieces is the same as having 1 out of 2 pieces. In terms of this represents the size of the piece, half of a piece of half of a pie, 1/6 of a pie. and then the top number represents how many. Some special notes. See, these are some things that you need to, we're going to use. They don't really have a rule or a general rule of thumb. But 3/8. This is how you would have to do that problem on converting it to a decimal. You have to know that 3/8 is the same as 3 divided by 8.
What did you say?
3/8 is the same as 3 divided by 8. So that means a fraction bar is the same as the division operation. And this is also the same as the number on top tells you the how many. So how many are there? There's 3. The number on the bottom tells you the size of them. So what's the size?
8.
An 8. So this is the same as having 3/8. 3/8 can be rewritten as 3 divided by 8, or it can be written as 3/8. And 8 is written as 1/8. That all means the same thing. One other special note is if you have something like this, x over 4. If there's nothing in front of the x, what number can be written there?
1.
So that's the same as 1x over 4. And then for the same rule as what we have up here, this and this can be rewritten as 1/4
Of x.
of x. Okay, so these are just special notes. This we'll use a lot because we're dealing with an algebraic class, so we're dealing with variables. Okay, but no real title, but just some special notes.
Maybe you need to do this more notes.
What's that?
Can I get the after outside of that where it says fractions?
Yeah. I'm going to go ahead and go over here, Bryce, but I'll leave this folded down. Okay. On this next flap over here, this flap is going to deal with everything with conversions. We've done a lot of problems this year where I told you that the answer was 29/4, and people have said, wait a minute, I got the answer 7 1/4. We've done a lot of problems where I've said the answer is 29/4, and people have said, wait a minute, I got 7 1/4. These are inevitably the same thing. One's written as an improper, one's written as a mixed. 29/4 is the what? This is the improper. And what makes it improper?
Big number of a little number.
Okay, so the numerator is greater than the denominator. That's what the definition of an improper fraction is. A proper fraction is when the numerator is smaller than the denominator. The definition of improper is when the numerator is bigger. And then 7 1/4 is called a mixed number. And the reason it's called a mixed number is because it's mixed. It's made up of 2 parts. One part is a, what kind of number? A whole number. The other part is a fraction. So that's the definition of what it means to be a mixed number. It is a whole number and fraction. In terms of doing algebraic equations, we always have to use improper. So that means that if we're going to do fractions without a calculator, we've got to know how to convert from one to the other. And then inside of this, I'm going to show you how to do each conversion. The first conversion is going to be going from mixed to improper. The first conversion is going to be going from mixed to improper. Okay, so here's what we're talking about. 3 1/4. That's a mixed number. Let's take a minute and draw this as a picture. 3 1/4 is 3 whole pizzas, right?
Yeah.
So what we're talking about is 3 whole pizzas and 1/4 of another pizza. 3 whole and 1/4 of another pizza. If we want to make sure that all the pizzas are cut into the same number of pieces, we can cut these 3 whole pizzas into how many?
4.
4. So, now that we've cut them into 4 whole pieces, we can think of it as part over whole. Part is how many you have, whole is the size of each. We're talking about fourths, that's the size of the pieces. How many pieces do we have that are fourths? We have 4, 8, 12, 13 fourths. So we have 13 pieces, and they are all of the size of being a fourth of a pizza. So 13 is how many? A fourth is the size.
Or we're putting anything in between the equal.
Yeah, I'm going to show you how to get it without the picture.
But now you multiply.
Okay, here's the process. I don't know if you've seen it this way, but here's how it goes. It's a drawing 2 arrows.
I think you showed this before.
Yeah, I think I have, yeah. You do 3 times 4, and then add 1.
Yeah, add 1.
3 times 4 makes 12, which that should make sense because each whole pizza represents how many fourths? 4. So we do 3 times 4 makes 12, plus the 1 extra. So 13 over.
And then you keep
4.
your denominator the same.
You keep your denominator the same. Go. So that's the rule. So for an example, 5 2/3. We don't want to draw a picture for this. Just go straight to the answer. 5 times 3 plus 2.
17.
So the answer is 17 thirds. Okay? So what we're going to do with these is when we get done, we're going to glue the back of these and put them in the very back of your notebook. That way, if you ever run into a problem with fractions, you can go to the back of your notes and find out the rules that you need to know for that problem.
Good thinking, Mr. McCain. Good thinking.
That's why they pay me the big bucks.
Big bucks.
Yeah.
Man, aren't you just rich for Catholic school?
All right, and then improper to mixed.
I wrote that on the wrong side. Can I write?
It's up to you. It's,
improper
yeah, it's how we're
Okay.
doing it. Yeah. Improper to mixed. We use long division with remainders.
I can figure out this.
That's why we're going over it.
Cool, that's great.
13 fourths. We made a special note over on the first flap that said 3/8 is the same as 3 divided by 8, right? So 13 fourths is the same as 13 divided by 4, which means we can rewrite it like this: 13 divided by 4 in terms of long division. Long division goes like this. You ask yourself, how many times does 4 go into 13?
2, 3.
4 goes into 13 3 times. What is 3 times 4?
12.
12. You subtract 1. There's nothing left to bring down, so this is called your
Remainder.
remainder. So the answer is 3 remainder 1.
I hate literally discounting.
Oh, yeah.
3.1.
Okay, so here's how you write that. How many times does 4 go to 13?
3 times.
3 whole times, and there was 1 left over. And what was we trying to divide the 1 by? We were trying to divide the 1 by 4. So 3 and 1/4.
Are we going to have to use this?
No, we won't deal with improper mixed unless we mix improper. Because we're going to always keep our answers in proper.
Are you taking a calculator away from us?
Part of the year, yeah, you're going to have to type.
Why?
Because we're going to be doing problems that involve fractions where you can't type in the calculator.
Why?
Yeah, so it won't really matter if we have.
Like, what do you mean?
All right. If I said, we're just solving 2 separate equations right now.
Oh.
If I said solve this, the calculator won't do the fraction work for you.
Yeah.
Because these are being subtracted. It's going to have to learn. Yeah. So you'll have to figure out the fractions regardless. All right, so 17/6. We treat this as a division problem. 17 divided by 6. How many times does 6 go into 17?
Twice.
Twice. 6 goes into 12 twice with a remainder of 5. So it goes into it 2 whole times and 5 out of 6 left over.
Whoa.
It's always, because what are you trying to divide the 5 by? You're trying to divide the 5 by 6. So it's 5 divided by 6. 2 and 5 6.
I'm glad we don't have to use this much. Because that'd be screwed.
Okay, that's conversions. Next class. Simplifying. Also called reducing fractions. You divide any common factor out of numerator and denominator. Okay, that's what we're doing. A common factor is a factor is a number that multiplies into the number we're talking about. So, for an example, the factors in 8 are 1 goes into 8, 2 goes into 8, 3 does not, 4 does, 5 does not, 6 does not, 7 does not, 8 does. So the factors of 8 are 1, 2, 4, and 8. So we're talking about finding numbers that multiply into it. An example of simplifying would be this, a very basic example. 15 over 30 is the same as 1/2. Okay? That's the kind of problems we're talking about. There's 2 ways of doing it. I'm going to show you 2 ways. It does not matter to me how you do it. I'm going to show you 2 ways to simplify.
So we're only using this one like, what is this?
I'll think about it.
Please.
That's a possibility. Yeah. Alright, so we've got 2 different methods. So we'll do method 1 and method 2.
Which one are we going on first?
And method 1 is successive divisions. Successive divisions by small factors.
I can say it word 5 times fast.
Successive divisions by small factors. So for an example, 12 and 72, regardless if you know the largest one, it can be done by successive divisions by small factors. So, well, first off, you might notice is they're both what kind of numbers? Even. So we can divide them both by 2. I'm saying we're doing successive division by small factors. So we divide by 2, which turns this into 6 over 36. Now, if it doesn't jump out that, hey, these are both divisible by 6, you could also say, well, we know they're both divisible by, well, they're both even, so they're both divisible by 2. Which gives you 3 over 18. And then these are both divisible by 3, which is 1 over 6. Now, you could have also, instead of doing that, if you realized it, you could have divided them both by 12, and you would have gotten to 1/6 a lot quicker. Okay? But if you don't see the largest, then you just start picking ones that work and just successively get smaller until you've gotten to where what goes into 1 and 6. The only thing that goes into those are 1. And dividing by 1 is not going to change it. So just doing small divisions successively. Method 2. Divide by largest common factor. Yeah, but it won't always be so easy. Like 30 and 105.
How much is that?
Well, that's, I'm going to show you how to know that.
Oh,
Okay, they're called factor trees.
I remember these.
The way you divide by the largest common factor is to find the largest common factor, we use factor trees. Yes, sir. Not me. Oh, gotcha. Yep, not me. That's all right. Bye. Okay. So we create a factor tree. So here's how we do this. You start off with both numbers, 30 and 105. You create a factor tree based on things that you know. Like, what do you know goes into 30?
15.
Okay, I heard 10 first. So 3 times 10. And then 10 can be rewritten as 2 times 5. Now when you look at factor trees, you just look at the ends of your branches. So we're looking at 3, 2, and 5. Now we don't go any further because what's the other thing that multiplies into 3? 1 and 3, 1 and 2, 1 and 5. So we've reached prime numbers, all prime numbers.
Wait, why do you circle the 5?
We have to circle what's on the end of all our branches.
Because you're gonna.
So see, 10 is not technically the end of a branch. 10 is a fork. These are the ends of our branches. Now we're going to go over to 105. Now 105 might not be as easy to see, but we definitely know it ends in a 5, so it's divisible by 5. 5 and 21. 21 is a common one.
3 and 7.
3 and 7. Does 3 and 7 go down any further?
No.
No. So that's the ends of these branches. And you ask yourself, what branches do they have in common? They both have a 5, and they both have a 3. So what we can say is the largest common factor is the combination of 5 and 3, which means the largest common factor is 15. So we divide them both by 15. And you get 2 over 7. Now, here's a convenient way of doing this. Guess what? When you divide them both by 15, here's the convenience of factor trees. If you divide them both by 15, you just mark these out. If you mark the 5 and the 3 out, what's left? 2. If you mark the 5 and 3 out here, what's left? 2 7s. So what's left in the factor tree is your reduced fraction.
Oh. That's always
That
going to work.
always works that way.
Oh, no, I hate math and I like some stuff like that.
Yep. If you eliminate what they have in common, what's left is your reduced fraction.
Can you read it from left to right now?
Well, top to bottom. So top over bottom, 2 over 7. Yeah. So I mean, that's actually probably quicker than actually dividing them by 15 if you've already made the factor trees. And you just mark out what they have in common and read. So this would have had a 3 over here still left. If it would have another 3, then you do 3 times 2. So the top would be 6 7s. Okay.
So you wouldn't use 3 again.
Well, only if they both had a 3.
Oh.
Only if they both had 2 3s. Okay, so that's another method. That's simplifying. Okay, jumping over to the next tab, adding and subtracting. We're going to do these all at the same time.
So
where are we at?
Adding, subtracting. Adding and subtracting, there's one rule. Must have a what?
Common
Common denominator. That should make sense because you're saying, I have this many pieces of pies, you have this many pieces of pies, how many are there total? In order to talk about them proportionally, they have to be the same size pieces. Because I can say I have 1 pie. That kind of goes back to that question of Johnny can say I have 1 piece, Eddie can say I have 1 piece. But if this is Johnny's 1 piece, he's doing a lot better off than even Eddie having 2 pieces. So they have to be the same size when you add and subtract pieces. And then you add or subtract the numerator, keep the denominator. Add, subtract the numerator, keep the denominator. Because remember, the number on top tells you how many there are. The number on the bottom just tells you the size of them. So if you add pieces, it does not change their size. Does that make sense to everybody? So if we're talking about a problem like this, 3/5 plus 1/5, they have a like denominator, which means they're the equivalent sizes. There's 3/5 here. There's 3 of them here. There's 1 of them here, giving us a total of 4/5, which we write as 4/5. The number on top tells you how many. The number on the bottom tells you the size of each. All right. We're going to use both flaps to do one problem on this one. So on the inside, we're going to use both of these. So to make sure there's no confusion, we'll just write like this. Unlike denominators. Okay. We'll probably run into these more often because there's an infinite set of numbers to pick from. So the chances that we run into a problem where all the denominators are the same is less likely when you start doing into the applications of this. So when there's unlike denominators, you must find the least common multiple. Now the key word here is least. It does not have to be a least. It could be any common multiple. It does not have to be the least common multiple. But if you don't pick the least, you're going to have to simplify your answer later on. So, yes, it is. So, for an example, 3/8 plus 5/6. So here's what you would do. You'd find the multiples of 8. You wouldn't need to write this out. This is what you kind of need to be doing mentally. Find the least common multiples of 8. It's 8, 16, 24, 32, and it would go on forever. You'd also need to find the multiples of 6.
Is that circling thing?
I don't know what you're talking about.
It's not like whenever you find a common one, you circle them.
Yeah, okay, yeah. So then you keep going, and then you...
But they didn't do like that, they did like this.
Because they didn't.
Come here, I'll show you.
Okay.
They're
They made
circling
it
both
one
of them at once.
Yeah, like it was one circle.
I don't know what you mean.
Like this. I don't have red on my hand. It's circled like this.
And so
Oh, I see.
I see.
I knew I wasn't crazy.
Okay, so first off, we have to find the least common multiple of each. And then secondly, we have to make them both into that multiple. So, what do we multiply 8 by to make it a 24? Well, which multiple is 24? It's the third multiple. So we times it by 3. But when we cut 8 pieces, we're taking each of the 8 pieces and we're cutting them into thirds. We're now tripling the total number. So instead of having 3, we're now going to have a total of 9. So we've got to times the top by 3 also. And then the 6 has to be turned into a 24, so we times by 4. So we're just taking each of those 6 and cutting them into fourths. So what we have now is 9 24ths. That's this 3 over 8.
And
Plus 20 over 24. And then we just follow the addition rule, which says you add the numerator, keep the denominator. So we have 29 over 24. Now that's an improper fraction. We want to give all of our answers improper fractions. So we do not change it to a mixed number. If we were to, it would be, how many has 24 go to 29? Once, and what's the remainder? 5. So it would be 1 and 5 24ths. Go.
gotcha.
There's this method, I forget what it's called. I don't know, crisscross applesauce or something. Have you guys seen that?
That ain't time I've heard that was
They take it
kind of hard to sit down.
Okay, well, it's crisscross something.
Anytime.
Okay. Here's another method. Now this is the method to find the least common multiple. This method always works. It says you multiply diagonally. You multiply by diagonally. So we'd multiply the 3 by the
So cross multiply.
6, and then we'd add 5 times its diagonal, 8, and we put it over the bottoms multiplied.
48.
So So you multiply the diagonals,
Like,
you multiply the diagonals, and you put it over top of the bottoms multiplied. So if you look, you get 18 plus, so 3 times 6 is 18, 5 times 8 is 40. So you get 58 over 48, which are both even numbers, which means they can be divided by 2. And dividing them by 2 gives us 29 over 24. So the whole point of that, guys, is, and here's technically what's point 1. If you don't know the least common multiple, then what you can do is just multiply this denominator by that one, and multiply 6
we're
by...
gonna do like one of them.
Do what?
We're gonna do one of them.
You do a check mark.
And you can do it either way. So I can multiply both this top by 6, multiply this by 8. General rule of thumb. That'll always work. The only thing to pay attention to is sometimes you will have to reduce in the end.
Oh.
If you don't pick the least common multiple, you have to reduce. So this method will always work. So if you're comfortable with reducing, that's the easiest way to remember it.
What if the bottom numbers, like the 58 over 48, what if they even? What would you divide by them?
Okay, it would just depend. Like if it was, say, 60 over 40. Let's say if it was
63 over 40.
Well.
63 over 48, for example. 63 and 48, they're not both even, but they're both divisible by 3.
Yeah.
So you divide by 3.
What if you want to divide by 6?
If 6 went into both of them, that would work. But 6 doesn't go into 50 evenly. Alright, so that's adding and subtracting. Multiplying is going to be its own tab down at the bottom.
I'm gonna do the last one.
Yeah, instead of being, well, we did adding and subtracting together. Guys, the same rule applies. If I was to give you a problem that had a minus, like if this was 3/5 minus 1/5, you would just do 3 minus 1, which would be 2/5. Okay, the same rules apply for subtraction. Multiplying, the rules for multiplying is you multiply straight across.
Well, this one doesn't matter if the denominator.
It does not. It does not. You multiply straight across, regardless of the denominators. So, and we can write that down. Denominators do not have to be equal. And then one thing to remember on these is when you multiply, you have to remember to simplify. And here's an example. 6 times 3/8. 6 times 3/8. Well, have to multiply straight across. Denominators do not have to be equal. Remember to simplify. Well, the issue is we have a whole number and we have a fraction. So we need them both to be fractions. So we're going to rewrite 6 as 6 over 1. And then the multiplication rule says you just multiply straight across.
So 6 times 3 is
6 times 3 is 18, and 1 times 8 is 8. Now, you have to remember to simplify. They can both be divided by 2. Division by 2 makes 9 over 4. Does anything divide into 9 and 4?
No.
No. That's as far as it goes.
So you do it like for the
4 doesn't go into 18 evenly.
Oh, yeah.
4 only goes into 16 evenly.
Oh, yeah.
Alright, so there's 2 methods. I'm going to show you the first method, which is probably typically how you've always seen it done. I'm going to show you a new method, which makes it a lot easier.
So we'll go all the way across to 2 different squares.
It's going to be 2 different squares. Method 1, method 2. Method 1, method 2. Method 1 is multiply, then simplify. This is how you've probably always done it. Multiply, then simplify. So for an example, it would be 5 over 7 times 14 over 15. Multiply, then simplify. So for example, 5 sevenths times 14 fifteenths. We multiply straight across. What's 5 times 14?
60.
What's 5 times 10?
50.
50. What's 5 times 4? 20. So 5 times 14 is 70. Remember, you just multiply by the individual parts. So this is 70. 7 times 15. What's 7 times 10? 70. What's 7 times 5? 35 and 70 make a total of? 35 and 70 makes a total of? 35 and 70 makes a total of?
105.
105.
I'm off by 10.
I did math.
Alright. Now, simplifying. These are both divisible by 5. It's however you want. These are pretty large numbers, so it might justify to make a factor tree. 5 goes into 70 14 times. 14 can be written as 2 times 7. 105, 5 goes into it 21 times. 21 gets broken down into 3 and 7. Here's the convenience about this. Remember, guys, you mark out what they have in common. So what do they have in common?
7.
They both have a 5. They both have a 7. The answer is what remains?
2/3.
2/3.
That's like that method.
That's why they do factor trees. Now, method 2 says do this.
Well, with the other two numbers up there, over there, does that, same thing?
Well, these aren't the ends of your branches, so you don't compare them. Yeah, you don't take into consideration these two because they're not. You only look at the ends of your branches. Simplify diagonally,
I remember this one.
then multiply. The convenience of this way is you can simplify with very small numbers. This is a much quicker way. 5 sevenths times 14 fifteenths. We're going to do the exact same problem. We're going to do the exact same problem. We're going to look at these diagonally. So 5 and 7 do not reduce. 5 and 7 do not reduce. 14 and 15 do not reduce. But if we look at it diagonally, let's compare 5 and 15.
3.
5 and 15 would reduce to 1 and 3, right? 5 over 15 is 1/3. How does 7 and 14 reduce?
2.
You divide them both by 7, the 7 becomes a 1, the 14 becomes a 2. So you get 1 over 1 and 2 over 3. Multiplying straight across, you get 2 over 3. So you reduce diagonally, then multiply. It's a much quicker way to do the problem now. Does not matter to me which method you want to do it. Either one works. I do the diagonal method. It's a lot quicker. Okay, and then the last flap is division. The rule of division is you cannot divide by a fraction. You can if you have a calculator. But remember, guys, we're going to get to where we're doing problems where the calculator, this can't be typed in the calculator. So you've got to know this concept. Cannot divide by a fraction. Now, that doesn't mean you can't get an answer. You can divide by a fraction technically, but the process of dividing by a fraction is multiplying by the reciprocal. But you can multiply by the reciprocal. And then so the problem is 3/8 divided by 1/4. 3/8 divided by 1/4. We can't do 3/8 divided by 1/4. So because we can't divide by 1/4, so we have to multiply by the reciprocal of what's being divided. So it's 3/8 times 4 over 1. And then we can reduce diagonally. Because once you turned it in, you just turned it into a multiplication problem. So now you just follow the multiplication algorithm, which says, well, let's reduce diagonally. 4 and 8 reduce to 1 and 2. So you have 3 times 1 on top, 2 times 1 on the bottom. So it's 3/2. Is there any questions on that? What time we got here? 10:23?
Yeah.
Okay. The bell's about to ring. Keep this. Bring it back tomorrow.